Let me tell you again today, the difference between this KH 550, 560, and 570. Sometimes some customers, this question is often asked, but actually, this question, we still have to talk about this principle of organic chemistry, because this 550 is aminosilane. You can think of it as an organic amine, 3-amino-propyl T-riethoxysilane. 560 is this epoxysilane, 3,2-epoxy-prop-oxypropyltrimethyl. And what about 570? It's methacryloxylane. Actually, you can think of it as an acrylic monomer. Its chemical name is 3-methacry-L-oxypropyl-trimethoxysilane. So this composition of it is different from the functional group. It causes its reactivity to vary greatly. Of course, 550 and 560 in practical applications, there might be some intersections. For example, in epoxy resin, polyurethane, acrylic acid. It can be used at the same time. This is 550 or 560. And what's the difference? It's obvious, actually. What about 550? As an aminosilane, it has relatively strong chemical reactivity, also has a certain yellowing. It's like an epoxy. You want to think of it as an amine? It's obvious. It's in this amine curing agent for epoxy. It can't be added to epoxy, because it is added to the epoxy resin. It is equivalent to, the curing agent is added to the resin. It's solidified directly. The same thing. 560 as an epoxysilane. It's actually a silicone epoxy monomer. It adds epoxy. Obviously, all epoxy systems are available. One component, latent type of this solidification system. It can be cured with acid anhydride or epoxy. Of course, amine curing can be used more. But what? It's all added to the epoxy resin component. In the polyurethane system, silane coupling agents like 550 aminosilane. Then it obviously cannot be added to the curing agent of NCO isocyanate. But 560 can. What about 550? Can be added to this resin. It's the polyol component. But what about 550? It's primary amino. It has two active hydrogens, so the reaction to the NCO is a bit too violent, but the 560 is fine. One more thing. It is this 550 that has better reactivity at room temperature, because its amino group is more reactive. However, 560 is used as an epoxy group. An epoxy-based open loop actually requires a certain temperature, or acid-base conditions, so it's at room temperature. Like some paint makers, glass paint, maybe it's baking conditions. 560 effect is okay, but if it dries at room temperature, it doesn't work very well. There's one more thing. Just 550 has a certain yellowing. 560 did not. You need to make something colorless, like varnish, or light color, even white paint, or adhesive. Then 550 can't be used. Here are a few differences between 550 and 560. Of course, there's another one. The hydrolytic stability of 550, better than 560. Finally, let's talk about this 570. 570 actually, it has unsaturated double bonds in its chemical structure. It's actually a monomer of methacrylic acid, so it is mainly used in some. This resin system reacts with free radicals. For example, unsaturated polyester resins like peroxide-induced cross-linking. And then, or like this peroxide cross-linked rubber, like silicone rubber, natural rubber, just rubber vulcanized with peroxide. You can use this 570 of methacryloxy. And of course, 570 has another important purpose. It's with this other acrylic acid, methacrylic acid, or monomer of styrene, copolymerize. Make some silicone acrylic emulsion, silicone acrylic resin. Last use, it's a methacrylic acid monomer. Can be used in UV, because it is like any other UV. Both contain double bonds. Can participate in this light-induced process. So these are the differences between the three silanes, 550, 560, 570. In fact, we still have to choose according to its chemical reaction principle. Select the appropriate silane in different systems. Although their names are not much different, but actually, the chemical properties are quite different. What about the specific use? You can consult our company's sales engineer, or leave me a message.
KH, your trusted expert in coupling agents.